Okay, today's video lesson, we're going to talk about significant figures. What significant figures are used for? It's the way to tell, once we have an answer, how many digits to keep in our answer, where to round to. As we go through and learn about significant figures, the very first thing we're going to just do is take a number and assign the digits a label. And all the label we're going to do is say that digit is significant or it's not significant. And that's simply it. And then once we've done that, we're able to determine where to round to. Bottom line, how many digits can we keep? Well, our answer can only be as good as our weakest measurement. So if we're measuring masses, whichever balance we use, if there's one better than the other, our answer can only be as good as our weakest balance. If we're measuring distances with rulers or whatever other device, again, our answer can only be as good as our weakest measurement. We can't just put 7 decimals down in our answer, all saying that's our best answer, because we may not have used an instrument that gives us 7 decimals in the measurement. On page 47, there is a table of statements that gives us the information that we need to determine when a digit in a number is significant and when it's not. All right. So these rules you do not have to memorize, but you do need to understand what they mean and what they signify. So what I'm going to have you do is I'll actually have you pause the video here in a second, and I want you to at least read through these statements. Or look on the ones on page 47. You can write them down if you want to in your notes. If you've got the notes printed out, then you've already got them in front of you. I'm going to have you pause it, and I'm going to come back and quickly put down how many digits are significant in each answer. Then from that will lead us into our next step, which will be the rounding. Remember, this isn't the actual rounding. This is just the first step to then we can lead to the rounding. So I will have you pause as I pause here, and then when you're ready, you can just hit play and we'll keep going on with the presentation. Okay, what I have here, I've put the number in blue that tells how many of the digits in that number are significant. For example, in the number 1 here, the statement says all non-zeros are significant. So if we have a number that all the digits are non-zeros, then all of those digits are given the label of significant. So we see 1,234, there's 4 digits, they're all non-zeros, so 4 digits in that number are given the label of significant. 1.295, there's 4 digits in the number, all 4 digits are non-zeros, therefore they're all significant, so there are 4 significant digits. 913 has 3 numbers in it, all 3 digits are non-zeros, therefore all 3 are significant, therefore the number has 3 significant digits. What I'm going to have you do is pause here and also look over the numbers and see as you go through these, see that you understand why I've chosen what I've done for the numbers. And I've underlined which digits we do pay attention to. Right. So again, pause this, kind of look over these, and we'll come back, and when you're ready, you can hit play and we'll talk some more. All right, so you might be thinking, man, that's a lot of rules. How am I going to remember that? Well, we'll do one better here. The Cliff Notes for sig figs. Here's what it is. When is the only times I don't worry about significant figures, or when do I not ignore them? There's only 2 times when you do not count a digit as significant, and they both involve zeros. The first time is anytime you have a number less than 1. Those beginning zeros are placeholders. Okay? We do not count those as a significant digit. Right? The second time that we do not count digits as significant is when there's a 0 at the end of a big number that does not have a decimal point. So for example, the number 10, there is no decimal point there. There's only 1 significant digit. 140, there's a 0 at the end, no decimal point. That one only has 2. 1200 only has 2. 120,000 only has 2. It is a very important piece of information to know whether or not there's a decimal point there at the end or not, because that truly is determining where something is getting rounded to. Now, if that's the case, those are the only two circumstances when you don't pay attention, then all the other digits are significant. Okay. All right, now what I'm going to do here is I'm going to jump to another slide, and I'm going to have you pause this. I want you to go through and determine how many significant digits are in each number. Refer back to the notes if you need to, and give you a couple minutes. When you're ready, then obviously play, push play, unpause it, and we will go through and talk about these. All right, so if we look at these, I've got the answers to how many significant digits are in each one. So we'll quickly go down here to the left-hand side. The very first one, all 5 digits are considered significant. Numbers larger than 1, decimal point at the end, all the zeros count. The second example, 0.004082 only has 4 significant digits. It's a number less than 1, so those beginning zeros are placeholders. We do not consider those significant digits. Remember, this is just a label. The last one, 0.0400, only has 3. It's a number less than 1. Those beginning zeros do not count. The ones at the end do count because, number 1, they're after a non-zero and there's a decimal in the point in the number. On the right, all of them count, so there's 7 there. The last 2 are very similar. The only difference between the last 2 is the very last one has a decimal point at the end. That completely changes how many significant digits there are. In the next to last one, 1,205,000 without a decimal point, there's only 4. The 1,205,000 with a decimal point are 7. Why is that? Well, because we're basically saying here we rounded to the ones place with the decimal point. Up here, by not having a decimal point, basically saying we've rounded to the thousands. That is very important to know that difference. Okay. All right, so you've got to understand when you look at a number how many digits are significant, because when we go to a calculation, here's how we know where to round. Now, the description's a little bit wordy, but we should be able to make sense of this as we look at the examples. So if we're going to add and subtract, one set of rules. The original number that's in the calculation with the least number of significant figures in the decimals. Okay? So the original number with the least in the decimals determines what the answer gets. All right, so at the very beginning I talked about the weakest measurement determines the answer. So let's look at 2 calculations here. 12.960, 13.0, and 24. We add those numbers together up on a calculator and we get 49.96. What do we round to? Well, what's our weakest measurement? That one has 5 significant figures based upon the rules. This one has 3. This one has 2. And again, we're talking about adding and subtracting, so we're looking at the decimal places. So we're not just looking at the whole number. We can look one step further and say, well, yeah, there's only 2, and oh, by the way, there are 0 in the decimal places. Therefore, the answer gets 0 in the decimal places. So, if we can't have any in the decimal places, we're basically rounding to the nearest ones place. So 49.96 becomes 50 with a decimal point. Again, the significance of the decimal point tells us we've rounded to the ones place. Now let's look at this one over here. In the decimal, 3. In the decimal, 1. In the decimal, 2. Our answer can only have 1 digit in the decimal places. So 49.97 becomes 50.0. This basically tells us round to the tenths place. Back here, we rounded to the ones place. That determines right there, once we've determined the number of significant figures in a measurement, the one that has the least determines how to round. All right, so what I'm going to do is I'm going to give you two more up here. And what I want you to do is, you can look at these here and you can obviously pause it if you want to copy them down. We've got two more sets of numbers here with answers. We just need to figure out how to round correctly. Well, if we're adding and subtracting, we've got 2 in the decimals, change colors here, 2 in the decimals, 3 in the decimals, 0 in the decimals. So our answer is going to get 0 decimal places. Therefore, we're going to round to the nearest ones place. So 364.130 becomes 364. In the other example, 2 significant figures in the decimal places, 3 in the decimal places, 1 in the decimal places. Therefore, our final answer can get 1. So we are going to now round to the nearest tenths. So 364.230 becomes 364.2. So that's how we add or subtract. I know both those are addition examples, but subtracting is the same way. Last thing we'll do here is we'll look at multiplying and dividing. All right, so multiplying and dividing, very similar, just one small little change. The original number with the least, okay, so that's still going to drive this. The original number with the least, now here's the difference, total digits. So now we're not just looking in the decimal places, we're looking in the entire number. The original number with the least determines the answer. All right. So we've got a multiplication and then a division. In this first one, we look at all the numbers, not just the decimal places. So in all of the numbers, that one has 4 significant digits. In this second number, 0.00040, these first zeros are placeholders. Remember, it's a number less than 1. Therefore, we only have 2 significant figures in that number. Therefore, our answer can only keep 2. So our answer will become 0.00053. We can only keep 2. Now we look at the other one, 1.320. We still have 4. 0.00041. We still have 2. That means our answer can only have 2 digits that are significant. Well, our number is 3,219.512195. What do you mean we can only keep 2? Well, the correct answer is not 32, right? Because it's a 3,000. What our correct answer is basically saying is we're going to round to the hundreds place because we can keep 2 significant digits. So that's where we're rounding to. Because there's only 2 here, that's all the farther we can round to. So our final answer becomes 3,200. The last one I'm going to just show you here, just to give you 2 more examples. If we look at here, we have 12.930 times 1.02, and then 24.90 divided by 0.00439. If you look at these here, this first number has 5, the second number has 3, so our answer can only have 3, 13.2. Over here, this number has 4 total. This number has 3 because those zeros don't count. Our final answer can only have 3, so 5,670. We're rounding to the nearest tens place. Okay, so hopefully that's a good beginning introductory video about significant figures, and we'll continue talking about that more in class.